Okay, so here we're in the next chapter, chapter 2, looking at rectangular coordinates and their graphs. So first we start out with the rectangular coordinates, which is basically just your x and y graph. And we have quadrants. So the first quadrant is here, second quadrant, third quadrant, fourth quadrant. We go counterclockwise, starting in the upper hand right. And then to label these, this is our x, this is our y, and so when I'm in the first quadrant, I always start at my origin, which is 0, 0, 0 for x, 0 for y, and then if I go to the right of 0, just like on a number line, it goes 1, 2, 3, 4, and so on. If I go to the left of that, that'd be -1, -2, -3, and then looking at my y's, when I go up, I'm going positive, right? Going up, so 1, 2, 3, 4, and so on. When I go down, that'd be negative, -1, -2, and so on. So when I look at that first quadrant, my x's are positive, and my y's are positive. And so this is kind of looking like a point. Remember, when you label your points, you always put your x first, followed by your y. So here's labeled just my x is positive and my y is positive. So that's just the way you look at your points. Whenever you have points, your x comes first, your y comes second. Over here, my point would be negative for my x and then positive for my y. Down here in the third quadrant would be negative, negative. That's what all your points would be labeled in the third quadrant. And then the fourth quadrant, all your points would be a positive for your x and a negative for your y. So those are how just all the points in each of those quadrants are labeled. Okay, next we take a look at the distance formula. Here's the distance formula. This is the distance between 2 points P and R. So this is my one point P, and this is another point R, and I'm finding the distance. And the distance between them is taking the difference of my x's and squaring it, and then taking the difference subtraction of my y's. The important thing here is make sure whatever point I start with, so if I start with 1 point, then I need to start with 1 point, it's x there, then I need to start with that same y value of that same point, okay? And then so I take the difference of my y's and then square them, and then once I have those two squareds, then I add them or sum them together. And once I do that, then finally I take the square root of this. And remember, when you take the square root, you always have positive and negative, but here we're talking about distance, so we're always looking at the positive one. So if I have 2 points P and R, so say I have a point here, say that's P, and I have a point up here, that's R. I want to find the distance between them, right? So I want to find this distance. Well, to prove the distance formula, we use Pythagorean theorem, which is a squared plus b squared equals c squared, right? So c is the hypotenuse, right? So here to use the Pythagorean theorem, I would need a right triangle. So if I go down this way, let me use a different color, go down this way, and go across this way, now I have a right triangle. So always opposite of the right angle is your C. It doesn't matter which one of these is B and which one's A, so I just let this be A and let this be B. And then I just have to square my A, square my B, add them together, and that will equal my C squared. Well, you can kind of see in this formula where this comes from, right? If I want to find my C, that means I have to square root both sides, right? Okay, so then I would get my C by itself by taking the square root of A squared plus B squared. So you kind of see that in your formula here, right? This is something squared plus something squared, just like your formula. Then we're square rooting that, and it equals C. So that's where you can prove the distance formula by using Pythagorean theorem, or you could prove Pythagorean theorem by using the distance formula. So here for these 2 points, basically this P would just have some x value. So P would be the point x1 and y1, and R would be the point, or I mean you can switch these. R would be the point x2 and y2. And then you can see where this form, like my A would be the distance from here to here, which is from x1 to x2, right? Because this point up here is x2. So it has the same distance from the origin, right? Same way I count over to the right. And then the difference of my y's, that would be my b, right? From here up to here. This one would be y1 and this one would be y2. And so that's the same distance as this side right here. Okay, so Pythagorean theorem is used to solve the distance formula, or distance formula is used to solve Pythagorean theorem or prove it in any ways. So let's do an example of finding the distance between 2 points. So here we have a point P, -8, 4, and a point R, 3, -2. So we are going to use Pythagorean theorem, or not Pythagorean theorem, excuse me. You could use Pythagorean theorem. It'd be the same thing, really. So the distance formula is the distance, right, d, the distance between P and R would be equal to, so that's what this is saying right here, the distance between P and R. So we can label these, it doesn't really matter which one. You can let this be x1, then this would have to be y1. That's just what you got to get in the habit of. Right, so whatever point you do start with, that'd be your 1 and 1. So x1, y1. This point would be x2 because it's my second point, and y2. So then whatever x you start with, if I could start with this one, x2, I could start with that one. So if I start with 3 here, that means on my y's, when I subtract my y's, I got to start with that same point, so -2 here. Okay, and then just be careful, now I'm subtracting my x1, which would be -8. So I'm subtracting a -8. Well, that's going to make a +8, right? And then I'd be subtracting my y's. So my first y, y1, which would be I'm subtracting 4. And then squaring it. So just -2 minus 4. That'd be -6, right? And then after I square those and add them together, I'm going to root them. So I can add these, I can get 11 squared, and then plus here -6 squared. Just be careful, notice I took down the parentheses on 11 because it was positive. Here I didn't take the parentheses down on -6 because it's negative, and whenever you square a negative, it's going to be positive. So you're always going to be adding. That's why you sum, like if you read the actual definition, it would be the sum. So you're always going to be adding. So you get 132 plus 36. Add those together. We get what, 168. So square root of 168, and then we can break that down. Oh, oops, sorry. Not 132. 121, right? Yeah, 121. Oops. Go back to my pencil here. 121. So that's not 168. That would be, oops. Heck. That'd be 157. Okay, and then you could try to break that down. But 157 is, right, 3 goes into it, 5. So that's not gonna break down at all. So it's just gonna be square root of 157, and that's your answer. So that's the distance, and we always put a plus and minus in front of this, but since we're doing distance, it's just going to be the positive root there. Okay, so here's a problem that you can do. Point P and point R and find the distance between P and R. So you can pause the video and go ahead and try this. Alright, so I'm going to do it now. So if you haven't got there, go ahead and pause it. Try it yourself. So I'm going to take my x1 and minus my x2, so I'm minus and a -5, and then I'm going to square it, and I'm going to add, taking my y1, so I got to start with the same point, right? So 5, and I got to subtract my y2, which is 1, and then square it, add those together, and then square root it. So we get 7 squared plus 4 squared. I'm going to square root that after we add them together. So 49 plus 16, so we get square root 65, and again, that's not going to break down. So the distance is square root 65. So this one you might have to think about a little bit. We have 3 points, M, N, and Q, and we want to know, are these vertices or are these corners of a right triangle? Alright, so if I have a right triangle, I ask what the vertices are, that means I'm asking for these, right? The corners of a triangle. So is M, N, and Q the triangles of a right triangle? Or the triangles, the corners of a right triangle, or what we call vertices. So if it's a right triangle, that means Pythagorean theorem would be true, right? So our a squared plus our b squared would indeed equal c squared if it's a right triangle. So we have to see, does it fit this theorem or this equation here? And if it does, like if we got 3 for 3 squared plus say 4 squared does indeed equal 5 squared, right? So if our distance was 3, 4, and 5, if from M to N, let me go ahead and draw this. The best thing you can do to draw this, instead of just trying to make it up, is actually to put it on an actual number line, or coordinate plane, right? That's what this section is about, coordinate planes. So you could put negative 2, 1, 2, 3, 1, 2, 3, 4, 5. So that'd be the point negative 2, 5. Another point 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then up 3, 1, 2, 3. So somewhere it looks, since this is not a perfect graph, it might not look like a right triangle, but that doesn't mean it isn't a right triangle. And then 10, negative 11. Oh man, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 10. So it might look something like this. So that is N, and this is Q. So we're asking, is this a right triangle? It might not look like it, but it might be one. Or it might look like one, but it may not be one. So we need to find this distance A, this distance B, and this distance C. Right? And then maybe the right angle is actually here, or it could be here, or it could be here. We don't really know. But notice that c squared is always the biggest, right? A squared plus b squared equals c squared. So whatever the distance is, whatever the greatest distance is, that's going to be our c. Okay, so we got to find the distance between, right here, we got to find the distance. So I got to do the distance formula 3 times. 1 here, 1 here, and 1 here. Okay, so if you want to, you could pause the video just to practice finding the distance. So here are the 3 distances I'm supposed to find. From M to N, from M to Q, and from N to Q. That would be the 3 sides of this triangle, and we want to see, is it a right triangle? And then here would be their equations. I did M, I let M be my 1s, my x1, y1, and then N be my y2, or x2, y2. And then same thing for the other one, but N on the third one, I let N be my x1, and that's what I start with. So I start with my point M first. As long as you start with whatever point first, then its coordinates need to come first. So if I want to start with Q, then I put negative 10 first and negative 11 first. So it doesn't matter, you'll come up to the same problem anyways. Okay, so if we go ahead and simplify those, we see we get negative 14 squared plus 2 squared, which is square root 200. Negative 12 squared plus 16 squared is square root 400, and again 2 squared plus 14 squared is another 200. So we can see square root 400 is bigger than square root 200 and square root 200, so this must be, C must be the square root of 400, and we see that the other two are smaller, so we need to see, now check. Okay, so if we set up our a squared plus b squared equals c squared, and that's the formula for a right triangle, right? And that's what we're trying to prove. So we know c squared is square root 400, or we know the c squared is square root 400. because it's the biggest, right? So c is always the biggest, and that means c squared would be always the biggest. It doesn't matter really which one we put as a, because they're the same. Okay. So now we're going to see if this is true. So those are my a, b, and c. So we need to square those, because it's a squared plus b squared equals c squared. So that'd be square root and square root cancel each other. So 200 plus 200 equals 400, and that indeed is true. That's a true statement. So that means our a squared plus our b squared equals c squared. So that means we have a right triangle. So the distances that we're finding a, which is square root 200, b, which is square root 200, and c, which is square root 400. And then we're plugging them in, square root, they're going to cancel. We add those up. It is equal to true statement, so that means that yes, it is a right triangle. So it is a right triangle. So that means that they are vertices. Those three are vertices of a right triangle. Alright, the next one deals with our points collinear. So we're looking at 3 points. So we have 3 points. If you want to, you can draw this on a XY plane. So we got negative 1, 5. 1, 2, 3, 4, 5, 5. And then 2, 1, 2. Negative 4, 1, 2, 3, 4. So right there. So that's P. This is Q. And then we have R, which is 4, negative 10. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're asking, are these collinear? Meaning, do they make a straight line? So if they make a straight line, right? So if these made a straight line, that means that the distance from here to here, so from the distance from P to Q, plus the distance from Q to R, so plus the distance from Q to R, would equal the distance all the way down, right? If I take the parts are always going to equal the total, right? The parts will equal the whole. So the parts of the line will equal the whole line. So I'm taking the part of the line, the two parts of the line, add them together. If they equal the whole distance, so the distance from P to R, then they would be collinear. Okay? So it's best to probably draw it out so then you can kind of see what you're doing, which one is the part and which one's the whole. But you can also just find the distance from the 3 points from each other, and then you just add the two smaller numbers to see if it equals the third number. So you don't necessarily have to draw this out to see which ones you need to be adding together. Just find the distances between all 3 points, right? So P and Q, P and R, and Q and R. And then see which number's the smallest, which two numbers are smaller, and add them together and see if they equal the largest number. And they would be collinear if they did. So go ahead and set these 3 distances up. Alright, so here they're all 3 written in the distance formula. So I have my P to Q here in blue. I have my Q to R, which is in purple, and then the black one here is P to R, which I didn't have enough room to write there. But you go ahead and try to simplify these and see if they add up to equal each other. Okay, so that's a little simplified. Negative 3 squared plus 9 squared square rooted, negative 2 squared plus negative 14 squared square rooted, and negative 5 squared plus 15 squared square rooted. So if you got stuck at endpoint, now you can keep on going. Okay, so there's all the basic square roots. Okay, remember when you square a negative, it's always positive, so you're always going to be adding these numbers, these 4 numbers here. Okay, then we can't add square root of 40 plus the square root of 40. I don't get the square root of 130, right? I got to break these down. They have to be the same type of roots in order to add them. So I need to break all 3 of these down. So go ahead and break all 3 of these roots down. Okay, so you break them all down, you get 2 root 10 plus 3 root 10 equals 5 root 10. And that is true, right? Since they both have root 10, now we can add their numbers out in front, or you can call them coefficients, right? 2 plus 3 is 5, so we get 5 root 10 equals 5 root 10. So that is a true statement. So that means the two smaller parts do equal the whole, so that means these are collinear. Yes, they are collinear. Collinear means that they form a line. So multiples, and then linear. Linear as in line. Probably spelled linear wrong, but that's okay. Collinear. Okay, here's the midpoint formula. That's finding the middle point, right? So that means I would need 2 points to find the middle of 2 points. And then find the middle of something, that's like finding the average. So really I'm finding the average between 2 points. So that's why I'm dividing by 2, because I have 2 points. I have 2 points, and I am finding the middle dividing by 2, right? Because I have 2 points. So I'm finding the average, 2 points divided by 2. So I got to find the middle of my x's. Right, so I have some line here, point here, P and R, and I want to find the middle. So that means I got to find my x values, find the middle of my x's, and then I got to take my y values and find the middle of my y's, and that would give me that midpoint M. So I take my x's. Doesn't matter which one I start with, but I'm going to add them. So that's the big thing about the difference between the distance form and midpoint is I add my x's. So 3 plus a negative 3. And then I average them. So divide by 2 because I have 2 numbers there. And this is a point, so put it in as a point. Here's my x, comma my y. And then I'm going to add my y's together. Here, this doesn't matter so much which one really comes first. I could mix these up because I'm adding. Because 3 plus a negative 3 is the same thing as negative 3 plus 3, so it doesn't really matter which one comes first, but it's probably a good habit. Whatever point you start with that same x and then same y. And I'm going to divide those by 2, so then we get 0 over 2, comma, negative 5 over 2, which simplifies to 0, comma. You could leave it as negative 5 halves, or you can put it as a decimal if you want. It doesn't matter to me. So there would be my midpoint M. So there would be my midpoint. So this midpoint would be 0, comma, negative 5 over 2. That would be the midpoint there. Here's another one. Go ahead and practice on this one. So do this example. Negative 5, comma, 8. So once I write this down, go ahead and pause the video, and then I'm just going to write the answer at the end, okay? So go ahead and pause the video, and then I'll just give you the answer. So the answer is negative 11 over 2, comma, 5. So that would be your answer to that problem. Okay, moving on, finding the endpoint. So this is using the midpoint formula, which is equal to, you know, the average of your x's, and then it's a midpoint, right? So it's a point, so this is the average of your x's and the average of your y's. Okay. So here you're given one point A, and then you're given this one is your midpoint. So that means 8 would equal x1 plus x2, because that's your x value of midpoint, right? This is my x value of my midpoint, and my x value is 8, so 8 would equal x1 plus x2 over 2, and your y is negative 2, and that would equal your y value of your midpoint. So negative 2, would equal y1 plus y2 over 2. So now I want to find out what x1 and x2 is. Well, x1 and x2 and y1 and y2 just represent the 2 points, the 2 endpoints. Well, A is one of the endpoints, so you can let negative 6 and 12 be x1 and y1, or you can let it be x2 and y2. Let's go ahead and let it be x. So negative 6 plus x2. So we don't have x2 yet. That's what we're going to be solving for here. So I'm really have 2 equations. And then negative 2 would equal my y1, which is now 12. Oops, why do I keep doing commas? y2 over 2. So now we're solving these 2 equations, and they're going to give us our third point, or second endpoint, You can let it be whatever letter you want to, say N. Okay. So I'm finding these. So how do I get rid of dividing by 2? Well, I multiply by 2 on both sides. So I get 16. Okay, so we multiply by 2 on both sides. This one's going to cancel out, right? This one we can multiply, we get 16 is equal to negative 6 plus x2. Remember, x2, that 2 is not multiplied by x or anything like that. It's just saying it's an x, it's your second x. So we're solving for x2. So we add 6 to both sides. We get 22. So x2 is equal to 22. So that means my other endpoint, the x value is 22. Now we can solve this other one. How do I get rid of dividing by 2? Multiply by 2 on both sides. So we get negative 4 is equal to 12 plus y2. Again, we're just solving for y2. So we just need to subtract 12 on both sides. And so we get y2 is equal to negative 16. So that'd be my y value of my other endpoint. Negative 16. Okay. So there you go. That's how you solve that. Here's another problem. If your midpoint was negative 2, 4, and you had an endpoint, negative 12, or 7, negative 12 is an endpoint. Go ahead and solve what is the other endpoint. So you can pause this video, go ahead and solve it, and then I'll give you steps how to do it and give you the answer to this one. So your x2 would be negative 11, so your other endpoint would be negative 11, and your y2 would be 20. So that would be it. That would be your answer. See if you got that. Here are the steps. Okay, so here are the steps. Set the midpoint equal to the midpoint formula by taking your x of your midpoint, negative 2, and setting that equal to x plus 2 over 2, and then take your y value and set it equal to your y1 plus y2 over 2. Then plug in your y1 and plug in your y2, and then you'd be solving. And to get rid of dividing by 2, you would multiply by 2, right, on both sides of the equation. So really you're taking negative 2 and multiplying by 2. You're taking 4 and multiplying it by 2. And then you are, instead of adding your x2 and y2, you'd be subtracting it. So I'd be subtracting 7. My x1. I'd be subtracting my x1, so I'd be subtracting 7. And on this one, I'd be subtracting my y1 on both sides, so that'd be subtracting a negative 12. And then you can simplify these for y2 and x2, and if you do, you get the negative 11 and 20. Okay, so now we're going to be finding ordered pairs. Ordered pairs means they're ordered, like meaning x comma y, they're in an order, so it matters which one comes first. X comes first, and pairs meaning I have 2 of them, right? So when I'm trying to graph an ordered pair, just x and y, right? We have our independent variable x. That means we get to choose whatever x is, right? And then we solve the problem for y, our dependent variable. So you can make a table here, x, y, and then you can just start picking numbers and plugging them in for x. So 0, so plug in 0. So y is equal to 4 times 0 minus 1. So that'd be negative 1. So there's your ordered pair, 0, comma, negative 1. So, and then you could graph it, 0. And so I go over 0, and I go down 1. There'd be my point, 0, negative 1. This right here was not a point. That was kind of just me labeling my origin. So there'd be your point, 0, negative 1. And I could do any other point. I could pick another x. Negative 1. Plug that in. Y is equal to 4 times negative 1 minus 1. So that'd be negative 5. So I'd go over negative 1. And I'd go down 5. 1, 2, 3, 4, 5. Oops. I didn't go over. Let's take that one back. 1, 2, 3, 4. So that'd be over negative 1, down negative 5. So negative 1, negative 5. And I could just keep on doing it, keep on doing it, keep on doing it. This is linear, right? Because it just has a single x. So that's a linear, so it's a straight line. So all I need is 2 points. Okay, this one right here is a little bit different, but again, it's an ordered pair, so you get to pick x's and y's. This one, since it's set equal to x, I probably want to pick a y first instead of an x. Because when I pick a y, I can solve this problem a lot easier than picking an x, because then I would have to solve for y. So picking a y is a lot easier because it's already solved. The equation's already solved for x. So you can pick any y you want. So you could pick 0. If I pick 0, I'd take square root of 0 minus 1. Well, that's a square root of negative 1, so that's an I. So I can't really graph that because that's an imaginary number. So I might want to pick y's. Here's where you got to think about it. I want to pick y so that when I subtract 1 from them, I get the square root of something I know, like the square root of 4. So if I pick 5 as my y, when I take 5 minus 1, I get 4, and I know the square root of 4 is 2, right? Or positive 2 or minus 2, right? So I could get 5 and I could get a positive 2, and I could do 5 and I could get a negative 2. So there I have 2 in 1 there, right? So then if I would graph this, I would go over 2, 1, 2, because I go over on my x's horizontally, and then I would go up 5, 1, 2, 3, 4, 5. Okay, and then I would go over negative 2 and go up 5. I can't plug in 0, so how about, what if I plug in 1? So there's no, plug in 1. 1 minus 1 is 0. Square root of 0, I know that answer. That is 0, and only 0. So I go over 0, and then I go up 1. So this is a parabola, right? Because to get rid of a square root, I would square. So I have an x squared, so it's a parabola. It's a quadratic. Same with this last one. It's an x squared, it's a quadratic. So here again, you could just pick any x that you want to because it's solved for y, right? So pick any x. How about 0? 0 squared. 0 squared is 0. 0 minus 4 is negative 4. So there's my y, negative 4. So I could graph it over 0, down negative 4. Right? And then I could do 1, because 1 squared is 1. 1 minus 4 is negative 3. So I would go over 1 and go down negative 3. I could do a negative 1. Negative 1 squared is still going to be positive 1, and 1 minus 4 again is negative 3, right? It's a quadratic. It stays balanced around that vertex, and it stays balanced around it. It's a U-shaped, right? Not a V-shaped, a U-shaped. So those are what those order pair looks like. Whenever you're doing anything with an order pair, you have an x and a y, just pick an x or pick a y and solve for the other variable. You can do that all day. It's the easiest way to graph, but sometimes it might be the easiest way, but it might be more to it, right? When I have a linear one like A, that's pretty easy. I just need 2. This one I need, and this one I both need the vertex and a couple other points, right? So it might be more tedious to do it this way, but it's definitely the easiest. Alright, so these are the problems that I want you to work on for this first section. Chapter 2 is page 178, 11 through 55, and that's every other odd. Alright, so that's 11, 15, 19, 23, and so on. Every other odd, and so on. Follow the pattern. Okay, you guys can work together on those. That's fine by me.